Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, number of music playlists. So we have n different songs, and we want to listen to goal songs. So this is basically the number of songs in a playlist. So you can think of your playlist with tracks like this, and this is how many songs we need to be in that playlist. And they say every song is played at least once. So what this means basically is that every song from these n different songs needs to be in goal. So let's say if you have 4 different songs, you need to have 4 in your playlist, at least 4, because you need each song to be played at least once. So that tells you already that that goal has to be bigger or equal to n. Okay? Say goal is G, and that's already what you see here in the constraint. Okay, so now we know this first property of our playlist, and then the second property is that you can't play the same song again until you have already k other songs that have been played. It's a little bit of a mouthful, and the description is like very poor here, but what it means is, let's say you play song 1. Let's say we have maybe 3 songs, and let's say k is equal to, let's say 2, right? So you play song 1, you can't play 1 here, no. You have to play 3, because now you have 2 other songs, and then you can play 1. And now for 2, you have 2 other songs that are played, and so you can play 2 again, okay? And for example, let's say if goal was 5, our playlist, so now we have 1 slot, 2 slots in playlist, 3 slots, 4 slots, 5 slots. So we can have this as a playlist. It's valid because 2 occurs only after k equals to after 2 other songs, and then 1 same thing. Okay, so that's sort of the idea. If we had the goal is 6, we can play 3 here as well. Okay, so now that these 2 constraints are clear, I hope. What's the goal of the problem? Well, we want to return how many possible playlists we can create. So of course different playlists, and the answer can be large, so when it's large we need to return this. So that's the idea. And if you look here, we can have up to 100 songs, so not too big. So let's see how we can tackle it. Okay, so by looking at this problem first, it's tricky. We don't really have any greedy or any sort of strategy that is clear that we can take. So in that case, we are looking for the number of possible playlists. So it's sort of a counting problem here, and so we should be able to just try all of them and count how many, right? And so that already tells you we can try to do some dynamic programming solution, and always dynamic programming solution. Let's start with the recursive approach. So for that, what is the state that we have? Well, we have the inputs that we have is n, goal, and k. Okay, so we could either try all 3 as our state, or maybe let's try to make it smaller, because this k, we probably can take it into account in some other way. And so here, what we want to find at the end is how many playlists, so let's call it count, we can get out of n songs for playlists with goal songs. So this is sort of the length of your playlist. Okay, I will just like change the parameters a little bit. So goal, just and n. And so what would be a sub-problem here? So let's just try to just make this in a more dynamic programming notation. So let's say count of I and j. So this would be basically number of playlists we can create of length I, right? That's the goal, is the length of the list of the playlist, and j different songs. Okay, so let's say this is the sort of the state that we have. Now can we do this? Can we find sub-problems here? Well, for sub-problems, and especially here because it's just a number of songs, then let's just try I minus 1 and j minus 1. Okay, so what if when we have, let's say, a playlist already of length I minus 1. So if we have a playlist of length I minus 1, then what choices do we have? Let's say I minus 1 and J minus 1 songs. So in this case, well, we can just either introduce a new song, right? So if we introduce a new song, let's call it song A maybe, then now the playlist length is I. And how many different songs we have? Well, it depends. If this song is a different song than the J minus 1 songs we have, then now we have a J songs. But if this song is the same, then now we have I length of the playlist, but J minus 1 songs. So this is just to get your thoughts moving a little bit here. Of course, we still don't know how do we figure out if this song is different or not. That's still a tricky part here. Okay, but at least we know that our states are likely, our subproblems are likely these two, to get IJ. Okay, so let's go back here again. So we have count of I and J. How do we get these subproblems? Well, let's say if the Jth song here is a new song, so either we are adding a new song, the previous state is that we added a new song. So in that case, how many playlists we can create? Well, it's going to be count of I minus 1. So the previous state is we had a playlist of length I minus 1, and then we added a new song. Now we have a playlist of length I, and we had only J minus 1 unique songs. How many we can have here? Well, depends on how many songs we have. So let's say we have n unique songs total. N unique songs. Then how many songs? This one is a new song. So how many unique songs do we have left? We have n minus j minus 1. So when we have j minus 1 unique songs, then this is the number of remaining songs that we can pick from to have a new song. Right? And so this is how many playlists we can create, because let's say the remaining songs we have are 4, 5, 6, 7, 8. And the playlist already has 1, 2, 3. Then we can either pick 4, or pick 5, or pick 6, or pick 7, or pick 8. And how many are these here? We have 5. So we can create 5 different playlists, because one playlist can be 1, 2, 3, 4. Another playlist can be 1, 2, 3, 5. Another playlist can be 1, 3, 6. 1, 2, 3, 6. Another playlist can be 1, 2, 3, 7. And so you get the idea, right? So we can create n minus 1 minus j minus 1 playlist, which is if we do n minus j minus 1 playlist, it's just going to be n minus j plus 1, right? Okay, so that's the first subproblem. Now, what other things should we add? The other case. Well, the other case is we have to play a song that we played before. So basically, let's call it replay a song. Okay. So if we are replaying a song, then of course we increased the playlist by 1, right? So it went from I minus 1 to I, because let's say you have 1, 2, 3, and you replayed 1. Now your playlist length it was 3 before, now it's 4. That makes sense. So it went from 3 to 4. That makes sense. But the number of unique songs, which is j here, didn't change, which is the second parameter, didn't change. We still have j songs. To be able to go from I minus 1 to j to ij, we need to already have had j songs to be able to replay the ith song in the playlist, to be able to have the ith song a replay of a previous song. Right? But how many do we have? How many playlists can we create out of this? Well, we have the constraint that you can't replay a song until you already have k other songs. So let's say whatever k was, to be able to replay 1, we need to have k songs here to be able to replay 1. If we had 1, 2, 3, to be able to replay this 3 here, we need to have k songs. Let's say maybe k was equal to 3, then we need to have maybe 4, 5, 6, and then be able to replay 3 here. So what does this tell you? Well, this tells you that the k previous songs cannot be replayed. So we know that we can't replay 4, we can't replay 5, we can't replay 6, but we can replay either 3 or 2 or 1. So the question becomes, how do we get this number of songs? Well, it's easy because it's just, we know that we have J unique songs. The K previous ones we cannot replay because 4 we can't replay it, 5 we can't replay it, so it's just J minus K. That will gives us the other ones that we can replay. So that means that here we should just multiply by J minus K. Okay, and that's it. And so these are the number of playlists we can play with the 2 different options. So what's the combination of the 2? Well, this is just the total number of playlists, so it's just plus. Now, one thing I want to iterate here is what's clever about this solution is that we don't actually go and check each solution and see did this specific song was replayed or not, because we care only about the number of playlists. We just count how many we have, how many we can do, and just add up the total. Okay, and once you figure this out, the problem is pretty much solved. The only thing you need to figure out is what are the base cases. Well, the first base case is that if I is equal to 0 and j equal to 0, so this basically means that how many playlists we can create with a playlist of 0 length, so with an empty playlist and with 0 songs. Well, empty playlist with no songs, that's just one playlist, which is the empty playlist. So here we need to return 1. And then the other case, what if I equal to 0 but j is some other different than 0? Then in this case, how many playlists we can create with no songs, even when we have j songs? So how many playlists of length 0 can we create that have j unique songs that j is different than 0? Well, the answer is 0 because it's not possible. And similarly, how many playlists of length I different than 0 in j equal to 0? So basically, how many playlists of length bigger than 0 with no songs? That doesn't make sense. It's not possible. So 0. So these are as our base cases, and this is our recursion iterations, and then we can just cache and get and solve it. Okay, so that's pretty much it. Now let's implement it and make sure it passes. Okay, so if we want to write the function here, so the state is I and j, and we have our 2 base cases, right? Which is that when both I and j are equal to 0, or when either one is equal to 0. So if both are equal to 0, we can create one playlist. If either one is equal to 0, we return 0. And then we have our 2 states that we saw in the overview. So the first one is, okay, let me just first get rid of the modulo so that this is clear. So the first one is I minus 1, a playlist of length I minus 1. And then we want, with j minus 1 different songs, to be able to get playlist of length I with j different songs. We pick a new song, and the number of possible new songs is I minus j minus 1. Okay? And then the second possibility is, let's actually make this choice 1 here. Let's call it pick a new song. Okay. And then the other choice, C2, let's call it, is replay a previous song. Okay, and here we are allowed only to replay j minus k, and I put 0 here so that we don't get a negative number, because we can't have a negative number of playlists, and so if we can't replay any songs, then this is just should be 0, right? So that's why we multiply by 0 here, if that's the case. And then the end, we want to return just the sum of the 2 possible playlists from each option. And now here we just want to call our function. So what is the state? So we want a playlist of length goal. That's what the problem says, and with n different songs, because the problem says we need every song played at least once. So this is what we want to return here. Now the problem also asks us to use a modulo 10 to the power of 9 plus 7 if the answer is big. So let's just introduce that. So we want to do like that, and we want to take the mod here, take the mod here, and take the mod out of the sum here. So that should be it. And we also want to cache, because this will get called on the same states multiple times, so we want to just cache. You can use a hash map, but I'll just use Python's cache here quickly, and that should be it. So if we run this, it should work. Okay, submit, and that passes. Okay, so yeah, that's pretty much it. The hardest part is figuring out how many playlists here you can construct, and once you have that, it should be done. Yeah, so that's pretty much it. Please like and subscribe, and see you on the next one. Bye.